Hi, hi everyone. So today we will discuss acid-base equilibrium or ionic equilibrium. So first of all, let us discuss the definition of ionic equilibrium. So ionic equilibrium is basically equilibrium which is established between the unionized molecules and ions or ionized in solution of a weak electrolyte. In solution of a weak electrolyte. For example, let us take any hypothetical molecule HX, which will dissociate into H positive plus X negative. So this side is unionized. It is basically a neutral molecule, and unionized side, unionized. And this side is ionized. Fine. Next, we have what actually are acids and bases. Like we have acids and bases. What are they? So earlier, many developments were made to explain the things regarding acid and bases. Definitions were mainly on the observable properties, such as taste, etc. Like you know that acids are something which are sour in taste and bases are bitter in taste. So today we will discuss a very nice concept of acid and bases, which is known as BRONSTED-LOWRY concept of acid and bases. So according to BRONSTED-LOWRY concept, I will be writing it as BLC, BRONSTED-LOWRY concept. An acid is a substance. So acid basically is a substance which will lose a proton, or which can donate a proton, or basically there will be loss of a proton, and a base is a substance which can accept a proton, like there will be gain of a proton. So now what is a proton? Proton is H positive ions. So this is the game of H positive ions. So acids are proton donors and bases are proton acceptors. So now we will discuss few examples of acid and bases. Okay. HCl plus water Yeah, here, if you see, there is a loss of proton from HCl molecule. HCl is losing a proton and changing into Cl negative, chloride. So HCl, there is a loss, and we know that where there is a loss of proton, it is an acid. So HCl is acting as an acid. So it is an acid. And here water molecule is gaining a proton. Like initially it was H2O. Now it has changed to H3O positive, which is a hydronium ion. So it is gaining a proton. So it will act as base. Fine. Next, let us take one more example. Yeah. So here, if you see, water is losing a proton and changing into OH negative. Like there is loss of proton from the water and it is changing into OH negative ion. So water is basically donating a proton to CO3 2 negative. So water is acting as an acid and CO3 2 negative is gaining a proton and changing into HCO3 negative, like carbonate changing into hydrogen carbonate. So there is a gain of a proton. So this will act as a base. Fine. I hope this is clear. Now next, you try a few examples. Identify the acid and base in this example. Pause the video and identify. So if you see here NH, there was NH4 positive. So it was having 4 protons and now it has changed to NH3, which is having just 3 protons. So there is loss of a proton. So this will act as an acid. And here water is gaining a proton and water will act as a base. Water is gaining the proton and changing into hydronium ion, and NH4 positive is losing a proton and changing into NH3. Okay, one more example. So again, pause the video and identify the acid and base in this example. Here, if you see again, NH4 is losing a proton and that proton is gained by CH3COO negative. So this thing, so this particular is acting as a base and this is acting as an acid. Okay, I hope this is clear. Hope you liked the video, you learned something new. And you can just subscribe if you like, do share it. Thank you.